Hello everyone, this is the week 4 video lecture for CIS 150. The things that we're going to do this week are going to be, one, you're going to have to take a quiz. So there is a quiz out there for chapter 2, so make sure you look at that and complete that. Once you start it, you'll only get 30 minutes to complete it. It's supposed to be closed note, closed book, but obviously I have no way to enforce that. So if you have questions, there will be well, I guess I won't make a discussion post for that. Just send me an email because I don't want you posting direct questions so everyone can see them. Second thing, we're going to go ahead and start with chapter 3. So those slides are already uploaded, and we're actually going to just finish that this week. So it's on you to make sure that you look through all the slides, make sure that you understand them, and we're going to go ahead and do an example today based off of some of the material from the slides, and then that's going to be it for chapter 3, and then we'll move on to chapter 4 next week. So next week you should expect a chapter 3 quiz. Okay. First thing I want to do is your homework. Hopefully you're able to get that completed and submitted by Sunday. If not, hopefully you'll be able to look at this, the code that I have here, and be able to understand maybe where you went wrong or something that you missed. So what I usually do, like I said, is go over the solution, and I will typically go over the solution line by line. So let's go ahead and look at the first one. I just put a description. This program asks the user to enter a name of their favorite city. Once they do this, the program will ask them which position to display. The program will then display the letter at the specified position. So first thing I know is that I'm going to need some kind of user input, some way to gather the information from the user. Okay. The second thing I know that I need, I'm going to zoom in just a little bit, is I know that I need to ask them what position do you want to display. So I need some kind of integer to store that value. Lots of times people are going to make this a char. We want that to be an int. Okay, because I need to know at what position is this particular letter. Okay, so it looks something like this. So if they put in Detroit, position 0, position 1, 2, 3, 4, 5, and 6, right? So if they said they wanted to see the D, they'd put in the number 0. Okay, and it might be confusing as to why that's 0, but that is just the way that it works in computer science. With strings and arrays, we start our counting at 0. Okay, so this is 1, 2, 3, 4, 5, 6, 7 letters, but we start our indexing at 0 and it goes to 6. Okay, from that point, I personally chose to store the letter that they requested in some kind of variable that is a char called char requested. I say char requested is equal to whatever the user entered, whatever that string was, dot at. That's what I wanted you to find. Okay, dot at. Or you could have done something like this. And either way works. User input, open bracket, char position, close bracket. And that works the exact same. Okay, so either way, whichever way you did that works perfectly fine. We'll get into why both of those work, okay, when we get to arrays, but either way works for this. Okay, you could have even just taken this and replaced it here and here. It really doesn't matter which way you do it, but typically if I can store something in some kind of variable, I'm going to go ahead and do that. Okay, so at this point, I just go ahead and do my output. The user entered whatever they entered, and the char at position, whatever position they gave me, is whatever that letter is. So we'll go ahead and give this a run. Okay, so it's asking me for my favorite city. Type in Monroe. What position? We'll just say 1, and we should get an O return. The character at position 1 is O. Okay? If you have questions about that, please let me know. Moving on to the other part of the homework, which I think is more difficult. Okay, remember this is like the change generator. The program asks the user to insert a dollar amount. Once the user enters the amount, the program will display the least number of bills possible to make that amount. And I just realized that I've spelled amount wrong every time that I used it. So the first thing that I would do, and you're going to look at this and say, man, how did you know to do all this? And I didn't know how to do all of this. Okay, I did not know that I needed all of these variables when I first started this. So the first thing that I would have done is I would have said enter a dollar amount and stored it somewhere. Okay, at that point, can I concatenate with this output here? The fewest number of bills to get blank is with some kind of divider. If I can get that, then let's move on to the actual algorithm. Okay, programs are broken down into three different things: input, process, output. You input the amount, I process it and give you some kind of display, and then I output it. Okay, the first one, you should have been able to get the first dollar amount fairly easy, right? If you owed someone $40, okay, and they gave you, let's just say that they gave you let's just say, like I said, you owe them $40. Okay, what's the fewest number of bills that you can get to 40? Well, wouldn't you just divide that by 20? And I owe you 40. 40 divided by 20, that's 2 bills. So I take the amount that you gave me, which is I owe you 40, and I divide that by my bill amount, and that's how many 20s I need. Okay? At this point, you should have been able to get to here. This is typically where I get a lot of questions. Well, I got 20s down, but I don't know what to do with 10s. And the issue comes with this line right here, okay? This amount to. Basically, what students will do is they'll come in and they'll say, I need this to be amount. Okay? Where let's just say that I owed you $50. Okay? And you say, example, let's just say example 1, I owe $50. Okay? So I'll say 20s is equal to 50 divide 20. So we'll say that 20s is equal to 2. Right? 50 divided by 20 is 2. At that point, students will forget this line right here. Okay? They will forget this line. And what they'll do is they'll jump down here and say, now I need to get my 10s. And they'll say, well, 10s is also equal to amount, which the user input and told us it was 50. And they'll say 50 divided by 10. And then they'll say 10s is equal to 5. And now, if you're giving me change at this store, I really like you. You are my friend because you just gave me a lot more money than what I really need. Okay? What you failed to do at this point was deduct the money that I already gave you, which is this line right here. And I'm just going to put this math is wrong because you did not deduct the money that was already given to the user. Okay? So at this point, we need to say amount to is equal to the original amount minus the 20s, which was already calculated, times 20. So do this math first. So we'll say 20 times 2 is 40. 50 minus 40 is 10. I owe you 10 more dollars. So now I say 10s is equal to the new amount 2 divided by 10. which is 10 divided by 10, which is 1. At that point, once you get the 20s and the 10s down, everything else should be some kind of copy and paste. This point, just make an amount 3. You don't even have to. You could just say amount 2 is equal to amount 2 minus 10s. I try to code this as if I'm you and keep it as simple as possible with all of these variables. Are there easier ways to do this? Sure. Are there different ways to do this? Yes. Some of you probably use the mod operator. Totally fine. Instead of doing this, you're using mod. That is totally fine to do that. Okay? Then at this point, it's just a matter of concatenating the output. The amount, $20 bills is 20s, $10 bills is 10s, $5 bills 5, $1 bills 1s, which are all of my variables up here. Okay? 20s, 10s, 5s, and 1s. This brings up kind of a unique question. Okay? And the reason I bring it up is for my computer science majors. Okay? The question that I have is, why does this work? Why does this algorithm work here? It's kind of a loaded question. You might not know what I'm getting to, but why can we just go ahead and take the largest amount and just work our way down, and it just happens to work out? Remember, the actual question I asked was, you need to show me the fewest number of bills. Another way to ask the question is this program here, can you guarantee me that it is giving me the fewest number of bills every time? Or is it just giving me some amount of bills, right? Maybe it's not necessarily the fewest. The math's right, but it could have been done in fewer. Think about that. What I'm trying to get to is that this is a very specific algorithm that we're working with, and this is what's called a best first algorithm. Best first. You'll go on, and if you want to get a bachelor's degree, you'll go on to start to look at algorithms and how can we make things better, and what's the best time complexity, what's the big O notation of this algorithm versus this algorithm. One thing that you'll go on to learn is that best first, this algorithm that we have incorporated here, is not a very good algorithm. It's not very good because this kind of methodology of take the highest first, then the second highest, then the third highest, and then the last, it doesn't always work. Here's another thing, okay? Pretend that there is a $7 bill, okay? So our currency now is 20, 10, 7, 5, and 1. Recode this real fast, and then you tell me if for some reason the United States had a $7 bill, if your program is right. Okay, pause the video, code this, mess around with this. You should have this done. If not, you should be copying what I have here. You guys are in a position where you can actually legitimately pause this and just copy it. In the past, students couldn't have done that, and I never upload this work. So the homework solutions will not be uploaded to Brightspace. Okay? Pause this. Tell me, did it work? The answer is no, it doesn't work. Right? You could have tested some numbers. You could have tested 20 and said, yeah, it works. You could have tested 50 and said, yeah, that thing works. You could have tested 45. Let's not say 45. You could have tested the 5, and it works. You could have tested 7. But what about the number 21? Or actually, let's do the number 14. Now you run your program and you tell me if it gave you the fewest number of bills. The answer is no. We'll say your algorithm would have produced this. You would have gotten 1. We'll say, let's just do this. A 10, a 1, a 1, and a 1, and a 1. That's $14, correct? However, the fewest is not a 10, a 1, a 1, and a 1. It's 5 bills. I can give it to you in 2 bills. 7 and a 7. That's the fewest way to get to 14. Your algorithm just failed. Remember, the end-all be-all question was fewest number of bills. Our money system in the United States is set up in a very specific way to allow you to jump to the largest bill and work your way down. If you've ever worked in retail, you probably know what I'm talking about. I worked at, while I was in college, a liquor store for 3 years. Right? You jump to the 20s or the 50s if you have some, and you just start to work your way down until you equal the amount that you owe them. If our money wasn't set up in that specific way, and for example, we had a $7 bill, it would take a little more thinking to get that done. Okay? If you have questions about this, this is just for fun, right? This is just to understand where we're going in the future, how computer science is just we're going to keep looking at algorithms and trying to make things better. Okay, if you have questions, like I said, let me know. What I want to move on to next is chapter 3. So I'm going to make a new project. Make a console app. CIS 150. The date. And then I'm going to call it set W, and we'll just say get line. And I want this to be stored right there. And I'm going to go ahead and click create. And I'm going to jump back to the slides. A lot of this I want you to review on your own. Okay? A lot of this I want you to just go ahead and review on your own. A lot of the stuff we should know. PEMDAS, right? And on slide, what slide number is this? Slide 12, PEMDAS. I'm trying to go faster through the slides. I heard that was an issue, that you guys didn't like me to spend time on the slides. So I'm just going to go quicker through it. And I'll just get right to the coding. So make sure you look through these slides, but a lot of the math stuff it's talking about we already know. So if you're using parentheses, you can negate PEMDAS if you want to. What I want to get to is 3.3, when you mix apples with oranges, or type conversion. Okay, so let's go ahead and get this project ready to go. And we'll say using namespace std. It was asked by one of my students, why wasn't indel working correctly? If you do not include namespace std, you have to say std : indel. Okay. Author, date, and you'll probably get a message down here about updating and downloading. You can do that if you want. It won't cause any issues, and I will too. I'm not going to do it right now during the video. Description, we are going to talk about casting, string concatenation, plus equals with variables, set W, set precision, and we'll say fixed, and get line. Okay, these are the things that we need to cover. So the first thing that I want to do is we're just going to go ahead and delete this. I would run that, but like I said, I'm trying to, I guess, speed up a little bit as requested. Let's just say that we want to get we want to get someone's full name. Okay, so think back to the city program, and if someone put in Ann Arbor, it would break our program. The reason that that's the case is because CN will read up until it sees a white space character. Okay, so let's do this. CN will read until there is a white space character. So the way that this works is that when getting user input, the user input is stored into a buffer, okay? So when the user types in the word Ann Arbor, okay, this is what's put into the buffer, okay? I guess I can just put it all, let's just do it like this. Yeah, that's gonna make it less confusing. Okay, this is what's stored into the buffer. And see, what the reason that we're doing this is because we don't want to read keystrokes as they're happening. Okay, I don't need to know that the user typed an A, then an N, then an N, then a space. Let them store it to the buffer and then I'll read it. Okay, so when they do this and they press enter, Ann Arbor is then stored into the buffer with the space. Cin goes through and it says, I'll read everything in the buffer until I see what's called a white space character. So a space, let's say this, space, new line, tab, and then we'll just put etc. Okay, it will read until it sees any of those things. Well, it's read into white space and it says, okay, that must be the end of what you keyed in. And it will take Ann and put that into your city. The way around this is to use getLine when there is a white space character in the user input. Okay, so let's say this, string full name. I'm going to get a red line. I guess it won't give me a red line yet. All I'm trying to get to is that you need to include string when using string. I thought that would be a syntax error. At this point, what do I got here? Let's just give this a run, make sure it's still running right. And it is just kind of a weird syntax error for some reason. At this point, what we're going to say is cout, enter your full name. We'll say getLine, and from here we're going to use, like I said, getLine because it's going to have a space between their first and last name. And the syntax for this is we'll put inside of the parentheses Cin, and then we'll put what variable we want to store that into. Okay? And at this point, I'll say cout with the string literal hello, space, and then their full name. Okay? And let's go ahead and give that a run. And we need to test this, like I said, with a space, just to make sure that it can read over the space. Oops, then I went ahead and didn't even test the right thing. And we get hello Zach Moore. So it was able to successfully read over that space. Okay, so what does getLine, where does it end? GetLine will read up until a new line character, also known as when you press enter. Okay, I'm going to do this. No, I'm going to pause while I do this. Okay, so I just went ahead and just looking at getLine, I'm going to go ahead and comment this out, Control-K-C. And the next thing I want to do is, we're going to say first, and we'll say first look at casting. And what I want you to do, like I said, what I would do for an in-class lecture is I would say, okay, now this is the problem I want you to work on. So pause the video, okay, and I want you to work on this problem. The problem is that I want to divide 10 by 3, and I want to see let's just say the decimal value. Okay, so divide 10 by 3, and I want to see the decimal value itself. So I don't want to just see 3, I want to see 3.333 with how many ever precision points you want. Okay? Pause the video, then see if you can get this done. So your first thought might be to do something like this, and hopefully you're able to get it done. But your first thought might have been this: int x is equal to 10, int y is equal to 3, double d is equal to x divided by y. However, this will not work. Okay, so this is what we talked about last week. I'm going to say this will not work because we are doing integer and integer division. Okay, so what we said that we could do was we could go ahead and convert one of these to a double, and we could say double. However, I want to show you casting. Okay, so down here we are working with typecasting, and there's 3 ways to cast something, and these are the 3 ways. I want to convert whatever ch is, which is a char, into an int. Okay, same thing here. I want to convert this char to be an integer. And then you can also still use, which I don't recommend that you use this static underscore cast. It looks like this. Static underscore cast, which means you want to cast this to a double, because students will typically get this syntax wrong. It's easier for them to get this syntax here. Okay, so what we can do is, and to be clear, what I was looking for was you to just do this: double y, double d is equal to x divided y. That will give you the answer. Okay, because that was the only way you knew how to do it. However, as it sits right now, this will not work. What I want to do is say double d is equal to the casting of, so convert x to a double, and then divide it by y. Okay? You could have converted y, you could have converted x, it doesn't matter, but the value d does have to be a double. Okay, so what I want to do is let's just do a simple cout x divided by y is equal to d, and we'll just go ahead and put an indel in there. And then let's just go ahead and run this. At this point we get 3.3333 repeating, okay, which is the right answer. One thing that I want to ask is, does this get changed in memory? Okay, so is x now, did we go to memory and did we say at this point, okay, now x is a double, meaning that it's 8 bytes? Is that what happened? Or did it only get changed for the computation here? Well, a way that we can look at that is we can say x is equal to 99.12. And then I just want to say cout of x. What am I doing here? All I'm trying to see is, will this display 99.12, yes or no? If it does, then this did go to memory and convert x to a double. If it does not, and it only displays 99, then it must still just be an integer. Okay, so let's go ahead and run that and see what we get. And we do just get 99. Okay, so what that's telling us is this only changes x for this computation. Okay, down here I'm just going to say proving that x is not changed in memory to a double. Think about what that would take. Okay, think about how hard that would be for the computer to go ahead and just look at this, go back to memory, dynamically reallocate memory to now be 8. That's a little bit harder. Okay, so it does not do that. So let's go ahead and comment this out. And then I'm just going to go ahead and grab this header because we're going to just keep jumping on to the next example. And hopefully you were able to read the slides before you got here. And this is all making sense. So what I want to look at is casting an integer to a char. And once again, this is another spot where I want you to stop the video and try this. Ask the user to enter a letter and cast that letter to the equivalent ASCII value. Okay? So, ask the user to enter a letter and cast that letter to the equivalent ASCII value. There is a key word here called cast. I'm asking you to cast it. I'm not saying just store a char in an int and let it just do the conversion by itself. That is not what I'm asking you. I am telling you that you have to use casting. Okay? So like I said, ask the user for a specific letter and then give them the ASCII value of that letter. So the first thing that, hopefully you're able to get it done, the first thing that I'm going to do is I'm going to write char letter, and that's what the user is going to input. And then I'm going to say int ASCII. I'm going to say cout enter a letter. Cin into letter. At this point, this is my input. Now I'll do my process. I will now say ASCII is equal to the casting of letter to an integer. Cast this char to be an integer and store it in this int. I understand you don't need this here, right? And that's what we went over last week. You could just, it would automatically do the conversion for you. But I asked you specifically to cast this, okay? Cout, and then let's just say letter, we'll say is equal to ASCII with an indel. Let's type in capital A, and I know capital A is 65. Okay, so I do know that that's right. Are there other ways to do this? Absolutely. You could have just went ahead and put this into here. You could have made this a string and then said let dot at 0. There are all sorts of ways. We are reaching the point, it's almost exponential as we move forward, the amount of ways that we could do this. Okay, so if you did it a different way and it still works, that's perfectly fine. That's the only thing I'm ever looking for, is if it works or it doesn't. Okay, I'm not looking to see if you matched mine exactly. Okay, so let's comment this out. The next thing that I want to talk about is we've been dealing a lot with concatenating output in regards to cout. Okay, but what I want to do is I want to look at concatenation in regards to strings. So I'm going to comment this out. Concatenation with strings. Okay, so what I'm going to do is I'm going to make a string and call it name. And I'll say this person's name is Beth. And then we'll say string hi is equal to hello with a space. What I want to do is I know that a way to concatenate this would just be name and then hi with an indel. But is there a way to actually combine these two and store them in another variable? And the answer is yes. So what we can do is we can say string greeting, or whatever you want to call it, is equal to hi plus name. All it's saying is take this and store that entire string inside of this string called greeting. Okay, and let's just do a cout on greeting with an indel. And then let's go ahead and give that a run. And we get hello, we got Beth hello. I did the wrong way. So we'll say hi and name. Run that again. And we get hello Beth, hello Beth. Well, another way that we could do this is string, and we'll just say message is equal to hello with a space. And then I'm going to say something different. I'm going to say message plus equals another literal, and we'll just say Bob. What this does is I'm going to say plus equals says take anything already stored in message and add the new string to the end. So this will essentially come out to be the same. And we'll give that a run. And we get hello Bob. All we said was, okay, hello is already stored in message. I just want to go ahead and just add right to the end of this. We see this a lot inside of computer science. Okay, where we're doing a plus equals. What we want to do is take a look at this in regards to integers. Okay, so I'm going to comment this out. Oops, did the wrong thing. And we're just going to say plus equals and plus plus with ints. So I'm going to say int num, and then I will say num plus equals 1, and then we'll say cout of num with an indel. Let's give that a run. This won't run. So give it a run, and you're going to get an error. Why do you think there's an error? It says uninitialized local variable num used. The reason that there's an error is because you want to add 1 to what's already stored in num. And there's nothing stored in num. So I'm going to say in order to use plus equals or plus plus, that variable needs to have something stored inside of it. Okay, so we have to, and let's just say this. This will not work. Work num has no value. However, if you said this, int num is equal to 5, this will work. Okay, and let's give this a run. And we get 6. Because what you said was take what's already stored in num, add 1 to it, and store it back into num. This is the same as doing that. This is the shorthand for num plus equals 1. And then I'll say this is the shorthand for num is equal to num plus 1. And let's go ahead and just do that up here. This is the shorthand for message is equal to message plus Bob. They all work the same. But all I'm trying to do is just make sure that you see numerous ways to do this. That way when you look online and you see some other code, you can read it and understand it. So we should get 7 because at this point we add 1, store it back in the num, that's 6. Add another 1, store it back in the num, that's going to give us 7. Okay? I'm going to comment this out and then grab this header again. We just have a couple more things. The next thing I want to do is look at combining chars in a string. So a string, like we said, is really just a sequence of chars put together in sequential memory locations. Okay, so one thing that I want to look at is combining chars and storing them inside of a string. So let's say we have a char, we'll just call it 1 is equal to, and notice I'm using this single quotes, an H, and then I say char 2 is equal to an I, and then from this, at this point what I want to do is say string is equal to 1 plus 2. And I need to give that string a name, and we'll just call it out. Out is equal to 1 plus 2. And notice that when we do this, we do get an error. And what the error is, I mean, you can hover it over it. No suitable constructor exists to convert into std basic string char. It's not going to help you. All we're saying is that this will not work because out has no value stored in it yet. Okay? There's nothing stored in out yet. So what we can do instead is say something like this. String out is equal to nothing. Just two double quotes side by side. It has no value in it yet. But then I can say out is now equal to 1 and concatenate 2 to the end of that. And we'll say cout of out with an endl. And let's give that a run. And we do get high. Okay, so this is a little bit weird here why this doesn't work. But the reason is because there was nothing currently stored, and you're basically trying to put chars in it, and it's just a little bit confused. Okay, so give it a starting value of nothing, and then you can go ahead and add these to it. So the final thing that I want to look at is set W, and we can look here at formatting output. There's lots of ways for us to format the output. Okay, but one of the ways is set W and it's X. That just means you give it an int. Print in a field at least X spaces wide. Use more spaces if field is not wide enough. Okay, all we're saying is that we want to have a designated number of spaces for everything to be printed. If it's not big enough, then just leave the spaces. That will help us get things lined up. Okay. The other things that we'll use, and you need to have these in your notebook ready to go, is fixed. Use decimal notation for float point numbers. That's just saying if it's a decimal, I want it to be shown in decimal notation. Set precision. When used with fixed, print floating point value using X digits. How many digits do you want to display for that double? And then show point, always print decimal for floating point values. We'll typically use these two. Okay? So let's go ahead and give this a look. And what I want to do is I want to say double num1 is equal to 22.33, and then we'll say double num2 is equal to 2.34. And then let's just say cout num1 with an endl, cout, oops, num2 num2 with an endl. And then let's just go ahead and give that a run. And notice that these are not lined up on their decimal. Okay? the hacky cheat way to do this, which will work 2% of the time, is to just come back here and do this. Put a space there. Now run them. Wow, they line up. Everything works. This must be the way to do it. It is a way to do it, but this is what's called hard coding. It means that this works for this example only. Okay, you can't say that this just works and lines up decimals. Will this line up? No, because you hard-coded in one space for that to work. At this point, you'd have to put spaces in this one. And now you have to edit the code based off of all the different numbers that we have. That is not how we want to do that. Okay? So, something that we can do, like I said, is use a set W. And what set W says is, these are how many spaces I want. Whether you fill it in with a letter or a number, it doesn't matter to me, but I need you to reserve me this many spaces. So let's just jump in here and let's just say we need 1, 2, 3, 4, 5, 6. Let's just say set W of 6. And I'm going to do the same thing, set W 6, and we have a red underline, so it says identifier set W is undefined. Well, let's go back to our PowerPoint slides. And it should say, in order to use this, we have to include iomanip in our header file. Okay, so this is something you have to remember to include if you're using set W. Put this in your notebook. If I get an email and say, why is set W not working, I'm going to direct you back to the videos. Okay? iomanip. And that just stands for input-output manipulation. And I'll just say iomanip is needed for set W, set precision, and fixed. So let's jump back down. I'm going to get rid of this space, and I'm going to go ahead and run this again. Still not lined up the way we want. So maybe it was because we didn't have enough space for them. Let's go ahead and put 7 in there. Still not lined up. What are we missing? Where we went wrong is that the way set W works is it says the next thing I will reserve 7 spaces for. So what you essentially said was, I need 7 spaces for this string literal, which is not true. So what you want to do is you want to move this over to the variable itself. So at this point what we said is we want 7 spaces reserved for these variables. And we can put some other things in here and just see if some of these other numbers work. And we are starting to get things lined up off of their decimal point. But notice if we keep extending this, whoops, we make it look like this, these aren't going to line up on their decimal point properly. The reason that it's not is because you said that you wanted 7 spaces reserved. Well, this is going to take more than 7 spaces to get everything lined up. Okay, so the number that you put in here has to match the largest number that you're going to try to display. Okay, we'll learn in probably a few more weeks how can we count all of these. That way, no matter what number the user puts in, we're able to line them up based off of their decimal. Okay, so what I'm going to do is comment this out, and we're going to look at one last example that I want you to work on. Okay, so the last thing that I want you to do is I want you to ask the user to enter 4 doubles. Line the values up on their decimal point, round to 2 decimals, and then at this point I want this to work, so I'm going to say this should work for any number the user enters. At this point, do you have the knowledge to do this right now? The answer is no. Because we just talked about how we can't justify that this will work for every number if they put 15 digits in front of their decimal. I've only accounted for 7. So what I'm going to say is largest value possible is 9999.999. Let's just say 99 because it's going to round to 2. Okay, this is the largest value that will work in this particular program. If the user puts something in larger, that's fine. It's not going to work, but that's not our fault. Okay, so this is something that we're going to have to deal with throughout this class. I always get asked a lot about error checking, and when will we get to error checking? We'll get to that in other classes, and I promise you when we get to it, you're not going to like it. So at this point, we should just move forward without doing any error checking and assume that they're going to follow the directions to only put in a number that is this large or smaller. Okay, so take 15-20 minutes to try to get this. All right, so hopefully you're able to get that done. What I want to do first is I just want to run you through some of the tests that I would do to ensure that I have the algorithm complete. This is something that is hard for students to grasp as well. Just this thought of you have to test this program with lots and lots of input to see if it works. Students will do something like this because they get in a rush. 1.2, 1.2, 1.2, 1.2, enter. They say, oh, it must work. It rounded, I got 1.20, and everything's lined up on the decimal. I would argue that you have no idea if this works yet. All you know is that if you put in the exact same number, you will line up on the decimal. That's the only thing you can say for sure, and that your program will round to 2 decimal places. A great test to do for this is to proceed with all the different possible inputs. What I mean by this is, okay, 1.2. That's one value, a decimal, and a value. 22.11. Two values, a decimal, and 2 values. 333.444. 3 values, a decimal, then 3 values. And then the max number, 9999.99. Does everything line up now? If it does, you're starting to slowly progress to say that this algorithm will line up based off the decimal point as long as you give me a number in my range. Okay, but to just test one set of numbers and then see if it works, it's just going to hurt you on the homework, because I run through a lot of tests on the homework to make sure that all the numbers are getting, or I guess it doesn't have to be numbers, but to just make sure that your program was not hard-coded in any way. Okay? So the first thing that I did was I said I need to have 4 doubles and I need to have 4 input statements. That's it. We should have all been there. That was last week's work. We should have all had this. If not, you need to send me an email. You need to get a hold of me, because this is building blocks. And if you can't get this done yet on your own without seeing my code, it will be a problem for the homework and the exams. Okay? At this point, I said I want the precision to be 2, and I want it to be fixed. I said that I want 7 spaces, okay, because the value was 9999, that's 4.99. 4, 5, 6, 7. The decimal does count. Okay, so I needed 7 spaces. Something that's not acceptable is to just come in here and say, well, I want 99. That ensures that no matter what they put in, it will work. That is not what I want. It is no different than you don't use double just because you don't want to have to worry about converting if you have to. Okay, so this is what your output should have looked like. And I'm okay if you didn't get this part, right? That's the new stuff. But to not be able to get the input from the user and store it, you need to get a hold of me so we can work through that. Okay? If you have questions, post them to the discussion board. Also, make sure that you look out for the quiz that will be coming up next week, and then make sure you take the quiz for this week. Okay, next week we get into the fun stuff, because next week we get into if statements, which having conditional statements is what makes a programming language a programming language. So next week you will be getting a homework, and it is one of the harder homeworks that I give. If you've heard anything from other students, it's the hangman assignment. So I'll give you 2 weeks to work on that, and it is a monster. You will need all 2 weeks. So enjoy this week off without having any homework, and then come back ready next week to get ready with the new homework. Okay? Like I said, if you have questions, let me know, and I'll see you in the next video.